This video is going to discuss electric field strength. By the end of this, you should be able to recite the equations and qualities of electric field strength. Let's get to it. So charges and electric fields. If two negatively charged balloons are brought near each other, they would repel because that's what like charges do. But why? All electric charges have electric fields around them. These fields are invisible to our eyes, but they're the cause of the electrostatic force. It's a field force. The fields interact, and that's what causes the force between them. When electric fields from two or more charges interact, electrostatic force either attracts or repels them. The field strength is really how strong the electric field is at any point, and it depends on two things: the amount of charge that's there, measured in coulombs, and the distance from the charge to the spot in space, measured in meters. So the equation for electric field strength is E equals kq over r squared. E stands for electric field strength, measured in newtons per coulomb. And the K could also be written, like on the AP equation sheet, it's written as 1 over 4 pi epsilon naught, just like Coulomb's law was. Same idea. This could also be represented using the electrostatic force, which from Coulomb's law. So you could have E equals F over Q instead of E equals KQ over R squared. These are synonymous with each other, in other words. So Q stands for charge, R is distance, K is the same thing as 1 over 4 pi epsilon naught, where Coulomb's constant, just like we talked about with Coulomb's law. As distance from a charge increases, its electric field has less strength. Kind of makes sense. The further from something, the less strong that field is. Just like gravitational forces. Planets that are further from their host star will feel less gravitational force than planets that are closer. As the amount of charge increases, the electric field strength also increases. So, for instance, if the sun doubled its mass, I mean, we'd have other problems, but the gravitational force would be greater for all the planets because if we'd like it, consider this similar to gravitational force. Charge, the more charge that's there, the greater the electric field around it. Time for a challenge question. If the distance from a charge is tripled, by what factor does its electric field strength change? If you're thinking 1/3, because it's, 3 times as far away, that's actually wrong. It's 1/9, because in the equation for electric field strength, it's kq over r squared. So it's an inverse square relationship, just like the law of gravitation, just like Coulomb's law. So it'd be 1 over 3 squared, which is 9, so 1 over 9. There's something called superposition, and superposition of anything means when there's multiples of something and trying to figure out like the force or the electric field because of multiple charges or sources or whatever. So superposition of charges, there could be more than one charge in a field. So the question is, if you have more than one, how do you figure out how strong the electric field is at any point between those charges? So in a situation like this, you would solve for the electric field strength at whatever point the problem is talking about. Let's say this is point P right here. You'd solve for the electric field strength separately for each charge at point A and the charge at point B, and then you determine whether you're going to add or subtract those two numbers depending on the directions of the electric field strength at that point P. So more on this when we get into problem solving, but basically you sort of think of it like net force diagrams, where you have electric field one way and another. If they're in opposite directions, you would subtract their values. If they're in the same direction, you would add them. So more on this when we get to actually solving it, but that's how you would go about doing it basically. So remember, electric field strength depends on the distance away from the charge and the amount of charge present. We'll apply this next class. Thanks for watching.